hopefully you know how to turn on your calculator and you've played around with it. There are 4 things you need to know how to do as far as College Board is concerned on the AP Calculus test, and that is graph in a specified window, find where 2 functions intersect, do a numerical derivative, and do a numerical integral. I'm going to show you how to do the graphing in a specified window, and then, you can decide what to do from there. And so, you're at your home screen. If you want to graph, we're going to hit this y equals up here. And here is where you'll type your function. So there is an X as a green letter down here, but we call this the variable button, xt theta n. If you don't have y equals, y equals, y equals, you're in the wrong mode. So we want to be graphing in function mode, not parametric, not polar, not sequential mode. So for example, if I was in the wrong mode, polar mode, when I go to y equals, I don't have y equals, I have radius. And when I hit this variable button, I get a theta because the input in polar mode is an angle. So I'm in the wrong mode. Make sure you're in radian mode, not degree mode, because we're in calculus here. And whenever you want to change mode, anything, whatever's highlighted, press enter. Okay. So back to y equals, let's graph sine of x. So I just hit sine, and then I put the x. I can close that if I want. And maybe against that, let's graph cosine of x, and let's move that up a little just so we can see the difference. So now I'm going to hit graph. If you have one of these nice color versions, that's really easy to see. If you hit trace, that just means you can press left and right like a bead on a wire and trace this. If you want to go from one function to the next, you just go up and down. And that's nice. Notice it tells you, hey, you're graphing cosine of x plus 2. And down at the bottom, we get an x and y coordinate. Changing colors, now we're on the sine of x graph, and that's from, or this is an ordered pair or something like that. College Board calls it graphing in a specified window because sometimes you need to change. So the window settings here, notice I've hit window, go from right now negative 10 to 10 on the x's, negative 10 to 10 on the y's. Hopefully x minimum and x maximum are pretty obvious. X SCL is for scale. So let's do this from negative 2 pi down to positive 2 pi on the x's. Notice it converts automatically, and we're thinking about sine and cosine. So let me just change from negative 1 to 1. And the y scales will be 1. So we'll look at those scales here. Now, it's still graphing, and you can see little tails, but the reason I don't see cosine of x plus 2 is, well, it ranges from positive 1 to 3. Anyway, so here is my graph, and the scale is these tick marks. So if I want to go back to my window and I want to change the scale, maybe I'll change this to every pi halves. So if I change that to every pi halves, that means this is 0, pi halves, 2 pi halves, 3 pi halves, 4 pi halves, or 2 pi. Hopefully that helps. Something else that might be useful, maybe you want to turn a function off, but know you're going to use it later. You can just highlight this equal sign, and then it won't graph. Now we couldn't see that before, so maybe if we change the window to x maximum, let's call this 10. Then we will be able to see, oh, not x, silly. Y maximum, we'll change that to 3. And so we think we're going to be able to see this cosine of x plus 2. We can't, it's turned off. Something else you can do, we can actually change over here. We can change the color if we wanted to. We can change the kind of line. You probably don't want to change those. And then I guess I'll just press OK here. Okay, so a couple other things. This zoom button in the middle, we haven't really traced. And under zoom boxes, you can draw a box. Zoom in is pretty obvious. We'll do that in a second. Likewise with zoom out. I recommend starting off at 6 zoom standard. Now you can press down, 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 down. Or you can just from the beginning push the number 6 and it will do standard. And that standard is negative 10 to 10 on the x's, negative 10 to 10 on the y's, and those scales are 1, which is nice. Let's go back and change. Let's get rid of this guy. So let's graph x and x squared. Okay, now these look a little bit weird, and the reason maybe it looks a little bit weird, we're supposed to have, not we, you and me, x is supposed to have a slope of 1. Well, the screen is not square. So built in here, if you want to know what things really look like, making the same distance between the x's on the x-axis and the y's on the y-axis, you hit zoom square. So you'll notice in the window, we get a different weird ratio of 10 to 16.097. You should probably know what that is. It probably involves some weird square root. Okay. So a couple of other things you might need to know. Maybe you want to know what x squared is at 2.1 and you're here anyways. Right here above Trace's calculations, so I hit the blue button. And value, I want to know a value of, let's say 2.1, is that what we said? And on, that's the wrong one. So at 2.1, x is equal to 2.1. But if we press up, we get x squared at x equals 2.1 is 4.41. Kind of cool. And we might as well, I'll show you the minimum. And if you can figure out minimum, you can figure out maximum. And then you'll be able to figure out a 0. So minimum, and I actually don't want to find the minimum of x. I want to find the minimum of x squared. So it says left bound. It's asking me to choose a number that is for sure left of the minimum I'm looking for. So I could trace over like that, and I'll just press enter. Right bound, I could go right, or I'm just going to press 1, and it says x equals 1, and I'm pretty sure I'm looking for something in between here. Notice it's like in between these two little arrows. Now, a long time ago, back when the 83s first came out in the 90s, it mattered. The guess just tells us, hey, get close. It'll run through fewer cycles, but not really a big deal. And so notice we get, and this is kind of weird, negative 1.625, which seems weird. But remember, this means 0.000000126. So that's x equals 0. And over here, oh my God, that's really y equals 0. 11 zeros before that too. So realize you're not going to get everything perfect out of your calculator. So that's the basics of how to graph.